Okay, guys, we're going to try this again. This is chapter 9, and we're going to try to go over this. It's called auxiliary views. There may be 4 parts. With as much trouble as I had on chapter 8, I may just divide this up in 8-minute segments, so that'll be for at least 4, maybe 5 segments, but I'm going to try to keep it to 4 if I can. So what we're talking about today is auxiliary views, and this is the objectives. We're going to create an auxiliary view from orthographic views, draw folding lines or reference plane lines that between any 2 adjacent views, construct depth, height, and width auxiliary views, plot curves on auxiliary views, construct partial auxiliary views, create auxiliary section views. So we're going to combine auxiliary views with what we learned in section views in the last chapter. Produce visions to show the true length of a line, point view of a line, edge view of a surface, and true size view of a surface. Number 8, show the true size of an angle between 2 planes, the dihedral angle. Construct the development of prisms, pyramids, cylinders, and cones. Use triangulations to transfer surface shapes to a development. Create the development of transition pieces. And number 12, graphically solve for the intersection of solids. And the last one is apply a revolution to show true length edges and true size surfaces. Okay, here we are understanding auxiliary views. Auxiliary views are useful for both design and documentation. Many objects are shaped so that their principal faces are not parallel to the standard planes of projection. To show the circular shape, true circular shape, use a direction of sight perpendicular to the plane of the curve to produce an auxiliary view. So if you look in that top view, you notice that in the top view that upper part is kind of turned at a 45-degree angle. And to get that true surface, if we drew that in orthographic views, in the front view and the side view, it wouldn't be true size and shape. To get the true size and shape, we have to draw 90 degrees to that angle so we can get the proper or true size of that shape of that upper part. Now, when we do this in the auxiliary view, the upper part is in true size and shape, but the lower part isn't. So that's a little bit of a difference. So here we are, the auxiliary view to show the inclined surface P, true size. The direction of sight must be perpendicular to the inclined plane. So that inclined plane is not vertical or horizontal. It's at an angle, so we're going to draw lines, project out 90 degrees from that angle. The auxiliary plane in this case is perpendicular to the frontal plane of the projection and hinged to it. It is angled to the horizontal top and profile viewing planes. So when we unfold it over in the right view, we can see we have a front view and a top view. And then when we unfold the auxiliary or the plane, we'll get the true size and shape of P, of that surface P only. The rest of it, is not true size shape. It's just the surface in that rectangle P is true size. Okay, primary auxiliary views. A primary auxiliary view is projected onto a plane that is perpendicular to one of the principal planes of projection and is inclined to the other two. So if you look at drawing A, depth auxiliary view, you got basically they're kind of doing a cutting plane line through there if you want to look at it that way. And then they draw the front view, and in the side view they put that cutting plane line PP or RP, and they show it in the auxiliary view, which is 90 degrees off that angle, right? And then you have your side view. In the side view and the top view, those shapes are the upper part of that piece is not true size and shape. The only way to get the true size and shape is to draw that auxiliary view. Again, only that surface is true size and shape. The rest of it is not. B, auxiliary height auxiliary views is basically the same thing. You're coming with your RP, line RP at the bottom there in the front view, going up to the top view, and you're projecting back down for your line RP to get that true size surface, true size and that surface on the right hand side. The part on the left hand side is not true size and shape. C, okay, that's the width. So you have a front view there and a right side view, and you're going to project. You're trying to get that base, the piece on the left, as true size and shape, because in the front view, that circular pattern or that arc and that circle is true size and shape. But on the left, the way that thing is turned, you have to draw that auxiliary view from the front view. From the side view to get the true size and shape of that base. Okay. And here's some examples of depth auxiliary views. All these views show the object's depth and therefore all depth auxiliaries. So I'm not going to go into that too much. That's really kind of confusing even to me. The front view and all these auxiliary views show the height of the object. Therefore, all these auxiliary views are height auxiliary views. Okay. Again, this is confusing, and I'm not going to go into a lot of depth on it. And there's the width auxiliary views. Same deal. Successive. From a primary auxiliary view, you start there. You got a front on the left hand side. You have a front view and a top view. You project down to your first auxiliary view there on the right, and you can keep projecting. As many times as you want, I guess, for what's called successive auxiliary views. Sometimes you may have to draw successive auxiliary views to get the right shape that you want. Here's secondary, sort of like the first one, I think. A secondary auxiliary view is projected from a primary auxiliary view onto a plane that is inclined to all three principal projection planes. So you have a front, right there in the middle, you have a front view and a top view, okay? And your first auxiliary is to the right. You're going to project down from the top view, and then you project back up to get that true size and shape of that circular pattern with the square in it on the right-hand side. Okay. I am going to stop there. That's almost 10 minutes, and we're going to see what we can do with this. Thank you.